Hi friends, I am SD Farande and today we are going to see the problems on spring, which is unit number 5 in our syllabus, and the unit name is the design of springs. Today we see the various problems related to spring design. Let's start the problems on spring design. A helical compression spring carries a load of 500 Newton with a deflection of 25 mm. म्हणजे एक हेलिकल कॉम्प्रेशन स्प्रिंग आहे ज्याच्यावरती 500 न्यूटनचा लोड असणार आहे आणि 500 न्यूटनचा लोड अप्लाय केल्यानंतर त्या स्प्रिंगचं डिफ्लेक्शन जे आहे ते 25 mm असणार आहे. म्हणजे स्प्रिंग जी कॉम्प्रेस होणार आहे ती किती होणार आहे 25 mm होणार आहे. The spring index may be taken as 8. स्प्रिंग इंडेक्स 8 दिलेला आहे, युनिटलेस क्वांटिटी असणार आहे. ॲज्युम परमिसिबल टाऊ म्हणजे परमिसिबल शिअर स्ट्रेस 350 मेगापास्कल. मॉड्युलस ऑफ रिजिडिटी 84 किलोन्यूटन पर mm². अँड व्हॉल्स फॅक्टर आपल्याला माहिती आहे, व्हॉल्स फॅक्टर या ठिकाणी डायरेक्टली दिलेला आहे 4c-1 डिवाइड बाय 4c-4 प्लस 0.615 डिवाइड बाय c, वेअर c इज द स्प्रिंग इंडेक्स. स्प्रिंग इंडेक्स आपल्याला पहिल्यांदा त्यामध्ये पुट करावे लागेल आणि त्याच्यानंतर आपल्याला मिळणार आहे व्हॉल्स फॅक्टरची व्हॅल्यू. फाइंड नंबर ऑफ ॲक्टिव्ह टर्न्स ऑफ स्प्रिंग. नंबर ऑफ ॲक्टिव्ह टर्न म्हणजेच काय, जे डिफ्लेक्शन होणार आहे, ज्या स्प्रिंगवरती लोड येणार आहे त्यामध्ये किती ॲक्टिव्ह टर्न आहेत. लक्षात आलं, म्हणजे ज्या स्प्रिंग ॲक्शनमध्ये असणार आहेत त्यांचा नंबर विचारला आहे, किती असणार आहेत ते आपल्याला कॅल्क्युलेट करायचे. सो फर्स्ट राईट द गिवन डाटा वेअर लोड इज गिवन 500 न्यूटन, डिफ्लेक्शन डेल्टा 25 mm, spring index is the 8, shear stress 350 megapascal converted into Newton per mm², and modulus of rigidity is 84 kilonewton per mm², convert it also Newton per mm². First, Hall's stress concentration factor is, it is denoted by K. We know that in our last lecture K is equals to 4c-1 divided by 4c-4 plus 0.615 divided by c. In that formula put the value of c, spring index, as a 8 and get stress concentration factor is K is equals to 1.184. Maximum shear stress induced is given by tau is equals to, we know formula, Hall's stress concentration factor K into 8WD divided by pi d cube. Here simplify it, K is equal K into 8WC divided by pi d square. We will write here pi because C is the capital D upon small d. We can put here C. Here capital D upon small d as a C we will put here, means D goes and here comes C, and instead of d cube here is the d square, means capital D upon small d is a C. From this we will get diameter of the wire, spring wire, d square is equals to K into 8WC divided by pi into tau. Put the values and get the diameter D is equals to 5.87 mm, and capital D is the C into D, spring index into wire diameter, means capital D is equals to 46.96 mm. Number of active turns is calculated from the deflection formula. डिफ्लेक्शनचा जो फॉर्म्युला आपण बघितलं होतं सुरुवातीच्या लेक्चरमध्ये, त्याच्यावरून आपण कॅल्क्युलेट करणार आहे नंबर ऑफ ॲक्टिव्ह टर्न्स. फॉर्म्युला काय डिफ्लेक्शनचा, डेल्टा इज इक्वल्स टू 8W d क्यूब इंटू n, small n, n is the number of active turns, divided by GD raised to 4. Put the values here, only small n is the unknown, so we can easily get the small n, which is 6.0190 means it is nearly, we can say 7. Total number of active turns are 7, which is asked in our problem. This is our answer. Let's see one another problem. Design a helical compression spring with grounded ends. या ठिकाणी एंड दिलेला आहे. ग्राउंडेड एंडसाठी जो फॅक्टर असणार आहे तो वेगळा असणार आहे. तो कुठला असणार आहे तो बघायचा आहे आपण. त्याचा एक चार्ट जो आहे, टेबल जो आहे, तो आपण आपल्या पाठीमागच्या लेक्चरमध्ये बघितला होता. कॉम्प्रेशन स्प्रिंग विथ ग्राउंडेड एंड्स ऑफ ब्रॉन्झ मटेरियल फॉर valve used in an hydraulic circuit. जे हायड्रॉलिक सर्किटमध्ये हेलिकल कॉम्प्रेशन स्प्रिंग वापरलेला आहे, ज्याचा एंड ग्राउंडेड असणार आहे, जो ब्रॉन्झपासून बनवलेला आहे. टेक फॉलोइंग व्हॅल्यूज. फर्स्ट गिवन इज द स्प्रिंग इंडेक्स C12. सेफ shear stress is 100 Newton per mm square. Maximum load W is given 100 Newton. Modulus of rigidity G is given 4 into 10 raised to 4 Newton per mm square. Deflection means delta is given 15 mm. And they are asking us find out diameter of spring wire means small d, diameter of spring coil means capital D, number of spring coils and stiffness of spring. First write down the given. Delta 15 mm, load W 100 Newton, spring index C 12, shear stress 100 Newton per mm square, and G modulus of rigidity is 4 into 10 raised to 4 Newton per mm square. Let's start. First, calculate Hall's stress concentration factor. We know that the formula K is equals to 4C minus 1 divided by 4C minus 4 plus 0.615 divided by C. From this we will get K 1.1194. After that, find the diameter of spring wire in small d. Maximum shear stress induced in spring material is given by tau is equals to K into 8WD divided by pi d cube. From this we will get small d, which is 5.85 mm, and mean diameter of spring coil is D is equals to C into D. Put the value of spring index and wire diameter and get the mean diameter of spring coil is 70.2 mm. Number of spring coils means number of turns, small n. It can be calculated from the deflection formula. We know that the deflection formula delta is equals to 8WD cube into small n divided by GD raised to 4. Put all the values and get the small n, which is 2.539. Number of spring coils or turns is n is equals to 2.539. We can say it is a 4 for safe design. Here one note is given. Minimum number of spring coils means active turns should be taken as 4 for safe design of spring and its proper functioning. म्हणजे त्या स्प्रिंगचं प्रॉपर फंक्शनिंग जर व्हायचं असेल आणि सेफ डिझाईनसाठी मिनिमम नंबर ऑफ ॲक्टिव्ह कॉईल जे आहेत ते आपल्याला 4 कन्सिडर करायचे आहेत. याच्या रिलेटेड जे प्रॉब्लेम सोडवणार आहे त्यामध्ये तुम्ही हे ॲझ्युम करायचं आहे की मिनिमम नंबर ऑफ ॲक्टिव्ह कॉइल्स किती असायला पाहिजेत, 4 असायला पाहिजेत. आता या ठिकाणी 2.53 जी आपली व्हॅल्यू आलेली आहे मिनिमम नंबर ऑफ ॲक्टिव्ह टर्न्स, याच्याऐवजी आपण 3 सुद्धा घेतलं असतं ते कदाचित चालू सुद्धा शकलं असतं, पण सेफर डिझाईनला जाण्यासाठी आपण त्याला 4 करणार आहे. लक्षात आलं. स्टिफनेस ऑफ स्प्रिंग इज S इज इक्वल्स टू W अपॉन डेल्टा, म्हणजे लोड अपॉन डिफ्लेक्शन असणार आहे. स्टिफनेस म्हणजेच व्हॅल्यू पुट केली, स्टिफनेस आपल्याला मिळाली 6.667 न्यूटन पर mm. We will see one another problem. A closed coil helical spring is used for front suspension of an automobile. ऑटोमोबाईलच्या सस्पेशन मध्ये एक हेलिकल स्प्रिंग वापरलेले आहे. द स्प्रिंग हॅज स्टिफनेस 90 न्यूटन पर mm with square and grounded end. The load on the spring causes a total deflection of 8.5 mm. By taking permissible shear stress of material as 450 megapascal म्हणजे टाऊ दिलेला आहे आणि विचारला आहे आपल्याला फाइंड spring wire diameter, length of spring, and assume spring index 6 and modulus of rigidity G is 80 into 10 raised to 3 Newton mm. Write down the given data first and let's start the solution of this problem. First, wire diameter of spring. We know that spring stiffness S is equals to load upon deflection, means load is a 765 Newton. Then Wall's stress concentration factor is K is equals to 4C minus 1 divided by 4C minus 4 plus 0.615 divided by C. Put the spring index value as 6 and get K is equals to 1.2525. Maximum shear stress induced is given by the formula tau is equals to K into 8 WC divided by pi d square. Put the value and get small d, wire diameter D is equals to 5.70 mm. This is our wire diameter small d. Next, mean diameter of spring capital D is equals to C into D, and mean diameter of spring coil is 34.2 mm. Next, they will ask in our problem length of spring. We know that the deflection of spring is delta is equals to 8W dq divided by dqn divided by g raised to 4, or we can write in the term of all spring index, which is 8WC cube divided by n divided by gd. Here we will put all the values and get the small n, which is unknown. Small n is the 2.93, means which is nearly equal to 3, we can say here. Given squared and grounded ends, therefore total number of turns is given by square and grounded ends साठी जी total number of turns असणार आहेत ती किती असणार आहे, n dash is equals to n plus 2. n is the active coils, okay, and n dash is the total number of coils, means 3 plus 2, which is 5. Solid length ls is equals to n dash into d. Put the value and get solid length is 28.5 mm, and free length is the LF is equals to n dash into d plus delta max plus 0.15 into delta max. This is formula, and we will get the free length is the 38.275 mm. See one more problem. A safety valve of 60 mm diameter is to blow off at a pressure of 1.2 Newton per mm square. Pressure दिला आहे ठिकाणी एका सेफ्टी व्हॉल्वचं. It is held on its seat by a closed coil helical spring. एक closed coil helical spring यूज केले आहे. The maximum lift of valve is 10 mm. Design a suitable compression spring of spring index 5 with an initial compression of 35 mm. The shear stress is limited to 500 megapascal and take modulus of rigidity G is equals to 80 kilonewton per mm square. Write the given data first and go for the solution. Design of helical spring. For designing of helical spring, we will calculate first diameter of spring wire, means small d. Load at which the valve blows off can be calculated as valve ज्या ठिकाणी blow off होणार आहे त्या ठिकाणचा लोड पहिल्यांदा कॅल्क्युलेट करायचा आहे. W1 is the load at which the valve blows off. W1 is equals to pressure on valve into area of valve. Pressure is the P and area is the pi by 4 into diameter of valve, means dV raised to 2 dV square. Put the value and W1 is the 3392.92 Newton. Maximum compression of spring is initial compression plus maximum lift of valve, means 35 plus 10, and delta max is the 45 mm. as the load W1 is 3392.92 keeps the valve seat with initial compression of 35 mm. Therefore, maximum load on spring for maximum deflection when valve is open is calculated as below. Means initial compression is 35 mm and W1 is the 3392.92 mm and maximum compression is 45 mm and maximum load W2. Means here we can calculate W2 from this. W2 is equals to 3392.92 into 45 cross multiplication divided by 35 is 4362.32 Newton. Valve's stress concentration factor K is comes here 1.3105. We know that the formula. Put the spring index and get this value. Maximum shear stress is given by tau max is equals to K into 8 W2 capital D divided by pi d cube, or apply the spring index here. Spring index C is equals to capital D upon small d, and it is a K into 8 W2 into C divided by pi d square. From this we can calculate small d. After simplifying, we will get small d is equals to 12.06 mm and mean diameter capital D is equals to C into D means 60.3 mm. Number of turns, it is calculated from the deflection formula. Delta max is equals to 8W2 into D cube divided by N into GD raised to 4. From this we will get small n and it comes 9.95 means nearly equals to 10 mm. This is the number of turns. Assuming square and grounded ends, total number of turns is given by n dash is equals to n plus 2, n is the 10 plus 2 12, and solid length is the ls is equals to n dash into small d, it comes 144.72 mm, and free length is the LF is equals to n dash into D plus delta max plus 0.15 into delta max. Put the values and get free length 196.47 mm, and pitch of the coil is P is equals to free length divided by n dash minus 1, and it comes 17.86 mm. This is our answer. Thank you friends.